0 to the 0 is not equal to 1. It can be defined to be 1, and it is convenient to do so sometimes, but it is not equal to 1. Let me show you why using a multivariable calculus explanation. 2 to the 2 is equal to 4. I think we can all agree to that because that is how exponents are defined, that 2 to the 2 is equal to 2 times 2. But what is 0 to the 0? The exponents, the way we define exponents, usually does not contemplate raising 0 to the 0th power. It doesn't contemplate either other expressions such as 2 to the pi. What does that mean? I can't multiply pi 2's together. So what do we mean by 2 to the pi? 2 to the pi is equal to 8.8249, etc. But how do we reach this value, and why are we in agreement that that is the value of 2 to the pi? We define 2 to the pi as a limit of fractional exponents of other numbers that we know are getting closer and closer to 2 to the pi. So we know how to compute fractional exponents because those are like square roots or more complicated roots, like a 10th root up there. So I can compute 2 to the 3, that's 8. I can compute 2 to the 3.1, 2 to the 3.14, 2 to the 3.141, and those numbers are getting closer and closer and closer to what the value of 2 to the pi should be. And in this way, I can compute 2 to the pi to any precision I want. But that's not the only way to compute 2 to the pi. I can approach 2 to the pi in many different ways. For example, here I'm going through 2 to the values that are approaching pi from above, 2 to the 4, 2 to the 3.5, etc. And it better be that if I approach 2 to the pi from some other direction, I still get the same value for 2 to the pi, and I do. And one can prove that the limit of the function x to the y as x goes to 2 and y goes to pi is always exactly this number, no matter how I approach 2 and how I approach pi. So what happens to the limit of the function x to the y as x approaches 0 from the right and y approaches 0 from the right? What number do I get? And like before, I hope that no matter how I approach 0, 0 in the first quadrant, that I get exactly the same value for the limit of x to the y. Otherwise, 0 to the 0 would not make sense. For example, I can approach 0 to the 0 as 0 to the 2, 0 to the 1, 0 to the 0.5, etc. And since 0 to any positive number is 0, the limit in that case will be 0. So is 0 to the 0 equal to 0? But here's another way to approach 0 to the 0. I can raise numbers to the 0th power and let that number go to 0. So 1 to the 0, which is 1, a half to the 0, which is 1, a fourth to the 0, which is 1. So the limit of that sequence is 1. So it doesn't agree. And you can approach 0 to 0 in such a way that the limit can be any number between 0 and 1. For example, the sequence that I wrote above is always equal to a half, so the limit is a half. But both the base and the exponent as n go to infinity go to 0. So I am approaching 0 to the 0, and the value is always a half. So if 0 to the 0 made sense, it would have to be equal to 1/2. So what this all means is that the limit of x to the y does not exist. And therefore, the value 0 to the 0 is what we call an indeterminate value. There is no single value I can give it to be that would make the function x to the y make sense at 0, 0. And that means that the number 0 to the 0 is not equal to 1, at least from the point of view of calculus and the real numbers. It can be defined to be 1, but it is not equal to 1.